How are different dam types built? Imagine controlling a mighty river or creating a reservoir that supplies water and power to millions. Building a dam is a complex process that varies based on the type chosen. Earth-fill dams, also called earthen dams, are made from compacted soil, sand, clay, or gravel. Workers layer these materials and press them down tightly to form a sturdy wall. They often include an impervious core made of clay or synthetic liners to stop water from seeping through. The upstream face may be covered with rocks or concrete to prevent erosion from waves. Construction can take several months to years, depending on the size, which can reach hundreds of meters long and over 50 meters high. These dams are popular where good soil materials are nearby and the foundation is solid. Rockfill dams are similar but use crushed rocks instead of soil. They also have an impermeable core to keep water out. The rocks are carefully placed and compacted to create a stable barrier. Because rocks are flexible, these dams perform well in seismic zones, absorbing ground movements without cracking. Building a rockfill dam involves sourcing large quantities of crushed rock, which can be transported by trucks or conveyors. The process can take a few years for large projects, and the size can reach over 300 meters in length. Concrete gravity dams are massive structures that rely on their weight to hold back water. They are made from mass concrete poured into formwork, often in sections. The concrete is allowed to cure, sometimes with embedded cooling pipes to prevent cracking from heat. These dams need a strong foundation, usually bedrock, to support their weight. Construction involves excavating the site, building formwork, and pouring concrete in layers. Large gravity dams like the Hoover Dam are over 200 meters long and over 70 meters high. They can take several years to complete, costing hundreds of millions of dollars. Arch dams are curved structures that transfer water pressure into the surrounding rock walls. They are built from reinforced concrete and are much thinner than gravity dams. The shape allows them to use less material while remaining strong. Building an arch dam requires a narrow, rocky gorge with solid abutments that can withstand the force. Precise formwork and careful concrete placement are essential. Construction can last a few years, and these dams are often less than 50 meters high but very wide at the base. Buttress dams use a series of supports called buttresses to hold back water. These supports are made of concrete or masonry and are spaced along the downstream side. The water's force is transferred through the buttresses to the foundation, reducing the amount of material needed. Building a buttress dam involves designing and constructing each support carefully to handle the load. These dams can be built in a variety of sizes, often in locations where material savings are important. Throughout history, dam construction has evolved from simple stone and earth structures to complex concrete and steel designs. Ancient civilizations used basic masonry and earth materials, but modern engineering uses computer models to analyze stresses and improve safety. Large projects like the Hoover Dam show how innovations in materials and design have allowed us to build taller, stronger, and more reliable dams. Dams serve many purposes, from storing water for cities and farms to generating electricity and controlling floods. The choice of dam type depends on the landscape, available materials, and what the dam needs to do. Whether it is a curved arch dam in a narrow valley or a broad earth-fill dam in a wide plain, each type reflects human ingenuity and our ability to shape the environment for better living.